Hello guys, my name is Devashish Tiwari. Today's topic is related to subject statistics. The topic is binomial distribution. Topic is related to subject statistics. This is the PDF of binomial distribution. P x is equal to x n c x p raised to the power x q raised to the power n minus x, where the range of x goes to 0, 1, 2 up to n, 0 otherwise. Now, in the case of binomial distribution, we calculate mean and variance. For mean, we know that mean is equal to summation over x is equal to 0 to n. Range of x px, where px is the probability distribution of binomial distribution. Now here it is clearly visible that the range of binomial distribution goes 0 to n. So x is equal to 0 to n x. The probability density function of binomial distribution is n c x p raised to the power x q raised to the power n minus x. So we also know that n c x is equal to n factorial upon x factorial into n minus x factorial. Put this value here, we get x raised n x n factorial n minus x factorial p raised to the power x q raised to the power n minus x. Now x raised to 0 to n x n factorial. Now expand x factorial x into x minus 1 factorial n minus x factorial p raised to the power x q raised to the power n minus x. Here x and x cancel. Now here x minus 1 factorial. So the summation goes on x equal 1 to n factorial divided by x minus 1 factorial n minus x factorial p raised to the power x q raised to the power n minus x. Now expand n factorial and n minus 1 factorial divided by x minus 1 factorial n minus x factorial p raised to the power x q raised to the power n minus x. Here multiply in numerator and denominator by p, where p is the probability of success and q is the probability of failure. So n summation x is equal to 1 to n minus 1 factorial divided by x minus 1 factorial n minus x factorial p raised to the power x divided by p into p into q raised to the power n minus x. This p comes out from the summation n into p. Summation x is equal to 1 to n minus 1 factorial divided by x minus 1 factorial n minus 1 factorial. This p goes upper, p raised to the power x minus 1 q raised to the power this whole expression is an expanded form of p plus q raised to the power n minus 1 using binomial theorem. We know that in binomial distribution p plus q is equal to 1. So n into p into 1 raised to the power n minus 1 is equal to n into p. 1 raised to the power something is always 1. So mean in binomial distribution is np. Now we find variance. We know that variance is equal to expectation of x square minus expectation of x whole square. Now we can write x square as x minus 1 plus x minus expectation of x. Now we calculate variance. We know that variance is equal to expectation of x square minus expectation of x whole square is equal to we can write x square as x into x minus 1 plus x minus expectation of x is whole square. Expectation of x is equal to np, where np is mean. Now expectation goes inside the bracket. Expectation of x minus 1 plus expectation of x minus expectation of x whole square. Now expectation of x minus 1 is equal to summation x is equal to 0 to n x minus 1 ncx p raised to the power x q raised to the power n minus x plus expectation of x is equal to np minus x np whole square is equal to summation x is equal to 0 to n x minus 1 n factorial divided by x factorial n minus x factorial p raised to the power x q raised to the power n minus x plus np minus n square p square. Now summation x is equal to 0 to n x minus 1 n factorial divided by x minus 1 x minus 2 factorial p raised to the power x q raised to the power n minus x plus np minus n square p square is equal to, here x minus 1 cancel, x is equal to 0 to n factorial divided by x minus 2 factorial p raised to the power x q raised to the power n minus x plus np minus n square p square. Now the expansion of n factorial is n minus 1 n minus 2 factorial. Using this n minus 1 comes out from the summation x is equal to 0 to n minus 2 factorial divided by x minus 2 factorial p raised to the power x q raised to the power n minus x plus np minus n square p square. Here x minus 2 factorial, so the summation start from x is equal to 2. n minus 1 summation x is equal to 2 to n minus 2 factorial divided by x minus 2 factorial p raised to the power x. Here we multiply multiplied by p square and divided by p square, q raised to the power n minus x plus np minus n square p square. P square comes out from the summation. The expression becomes n minus 1 p square summation x is equal to 2 to n minus 2 factorial divided by x minus 2 factorial. Here p square 2, it becomes x minus 2 q raised to the power n minus x plus np minus n square p square. The whole expression is an expansion of binomial theorem. It becomes p plus q raised to the power n minus 2 plus np minus n square p square. P plus q is equal to 1. When we calculating mean, we see that p plus q is equal to 1. Now expression becomes n minus 1 p square. It becomes 1 raised to the power n minus 2 is equal to 1 into 1 plus np minus n square p square. Now the last line is n minus 1 p square into 1 plus np minus n square p square. Variance of x is equal to multiply n into n square into p square. N square p square minus p square plus np minus n square p square. Here 1, okay, cancel. Variance of x is equal to np minus np square. We take common np from this expression, 1 minus p. P plus q is equal to 1. From here q is equal to 1 minus p. From here variance of x is equal to npq. So in the case of binomial distribution, variance of x is equal to npq and mean is np. We see that mean is greater than variance in binomial distribution.